0.60 moles per dm cube, D 2.80 moles per dm cube. Now solubility is equal to mass over molar mass multiplied by 1000 over volume. Now the mass is 0.28 grams, so that is 0.228 divided by the molar mass, which is this, x equals 56 grams, that is 56.0 multiplied by 1000 over volume, which is 100 cm cube, so that is over 100. Now if you solve that, the answer is 0.05 moles per dm cube, and that is option A. So option A, 0.05 moles per dm cube, is the answer to the question. So please subscribe to this YouTube channel for more videos and more past questions and answers. Thank you. I'm going to be answering WAEC 2019 Chemistry Objective Past Question 18. Vinegar is an aqueous solution of A. Hydrochloric acid, B. Ethandoic acid, C. Ethanoic acid, D. Hydrofluoric acid. Now first things first, what is vinegar? Now vinegar is basically a solution or a substance, a liquid substance, that is made up of ethanoic acid, an aqueous solution of ethanoic acid mixed with some flavorings and also mixed with some trace chemicals. So for hydrochloric acid, which is HCl, the aqueous solution of it basically retains the physical and chemical properties of hydrochloric acid. The same thing for ethandoic acid, which is C2H2O4. Aqueous solution still retains physical and chemical properties specifically of ethandoic acid. For ethanoic acid, we've established that a mixture of it with other substances gives us vinegar. Then for hydrofluoric acid, which is HF, the aqueous solution of it also retains the chemical properties of hydrofluoric acid. So, having established the fact that aqueous solution of ethanoic acid mixed with other substances gives us vinegar, our answer is C, which is ethanoic acid. So please subscribe to this YouTube channel for more videos and more past questions and answers. I'm going to be answering WAEC 2019 Chemistry Objective Past Question 19. Which of the following solutions contains 1 mole per dm cube of the solution would have the lowest pH? A. Ethanoic acid, B. Hydrochloric acid, C. Sodium chloride, D. Sodium hydrogen trioxocarbonate 4. So you are basically the question asks which of the following substances has the lowest pH, if you are to rephrase. And by pH, what is meant is the degree of acidity of the substance. Also, it can be expressed as the concentration of hydrogen ions in the substance. So that is the pH of the substance. Now, the pH of the substance is measured using a pH scale. And basically, a pH scale has values ranging from 0 to 14. So, from 0 to 6, values from 0 to 6 are acidic. Values of 7, or the value 7, is considered neutral. Meanwhile, from 8 to 14 is considered alkaline. So these are the pH values. So for ethandoic acid is a weak acid. And since it's a weak acid, it has values ranging from around 4 to 6. Now for hydrochloric acid, it has a pH value of about 3.01. Sodium chloride has a pH value of about 7, so it is considered neutral. And then sodium hydrogen trioxocarbonate 5, or sodium hydrogen trioxocarbonate 4, has a pH value of about 8.3, between 8.3 to 9. Hence, it is considered alkaline. So from this question, the lowest pH is hydrochloric acid, and hydrochloric acid is option B, which with a pH value of 3.01 has the lowest pH and is the answer to this question. So please subscribe to this YouTube channel for more videos and for more past questions and answers. Thank you. I'm going to be answering WAEC 2019 Chemistry Objective Past Question 22. Consider the following reactions. So you have aluminium hydroxide reacting with tetraoxosulfate 6 acid to yield aluminium tetraoxosulfate 6 and water. How many moles of tetraoxosulfate 6 acid is needed to proceed 0.5 moles of aluminium tetraoxosulfate 6? A. 0.5, B. 1.0, C. 1.5, D. 3.0. Now looking at the reaction, we see that 3 moles of tetraoxosulfate 6 acid, that is 3 moles of H2SO4, will react with aluminium hydroxide here to give just 1 mole of aluminium tetraoxosulfate 6. So we have just 1 mole produced. So the question asks, how many moles of tetraoxosulfate 6 acid is required to proceed 0.5 moles of aluminium tetraoxosulfate 6? So let's call that amount, that number of moles, of tetrahydrosulfate 6 acid required as X. Let's call it X, which is our unknown number of moles. Now, if 3 moles of H2SO4 produces 1 mole of this, so I'll add 1 here, that is 3 moles produces 1 mole. How many moles will produce 0.5 moles? Now, by simple cross multiplication, X moles will be equal to 3 multiplied by 0.5. And that is equal to 1.5 moles. So this means that 1.5 moles of tetrahydrosulfate 6 acid will be required to produce 0.5 mole of aluminium tetrahydrosulfate 6. So our answer is C, which is 1.5 mole. So please subscribe to this YouTube channel for more videos and for more past questions and answers. Thank you. I'm going to be answering WAEC 2019 Chemistry Objective Past Question 23. Which of the following pair of substance has the highest neutralization? A. Strong acid and strong base. B. Weak acid and weak base. C. Strong acid and weak base. D. Weak acid and strong base. Now, first things first, what is a neutralization reaction? Now, a neutralization reaction is one that involves, or is a reaction between an acid and a base to yield a salt and water. Now, an acid is a chemical substance that dissociates in water to liberate hydrogen ions, while a base dissociates in water as well to liberate hydroxyl ions. So what differentiates a strong acid from a weak acid? A strong acid dissociates completely to yield hydrogen ions. So complete dissociation and a strong base dissociates completely as well to yield hydroxyl ions. So for a weak base, there is complete dissociation and hydroxyl ions are liberated. So when a strong acid and a strong base react, the complete dissociation of the hydrogen ions and the hydroxyl ions brings about ready formation of water. And because the positive ion has been dissociated from the acid and the negative ion dissociated from the base, the remaining part of the acid reacts with the remaining part of the base to form the salt. So, for example, if you have the strong acid as hydrochloric acid and the strong base as sodium hydroxide, when the hydrogen ion is liberated and the hydroxyl ion liberated and water is formed, the sodium ion, which is the remaining part of the base, reacts with the chloride ion to give sodium chloride, which is a salt. So because of this complete dissociation and liberation of hydrogen and hydroxyl ion, the neutralization is very, very strong. Now for weak acid and weak base, an example of a weak acid is acetic acid. Acetic acid is an example of a weak acid. Now when acetic acid reacts with a weak base such as ammonia, there is partial dissociation of hydrogen ions from acetic acid and partial dissociation of hydroxyl ions from the ammonia, and for that reason salt and water isn't readily formed because of the partial dissociation. Similarly, when a strong acid reacts with the weak base, because the weak base does not liberate all its hydroxyl ions, neutralization to form a salt doesn't take place very easily, and also the same for weak acid and strong base. So from the explanation given, the strongest reaction or the highest neutralization is between a strong acid and a strong base, which is option A. So please subscribe to this YouTube channel for more videos and more past questions and answers. Thank you. Hello, I'm going to be answering WAEC 2019 Chemistry Objective Past Question 24. When quicklime dissolves in water, A. Heat is absorbed, B. Heat is evolved, C. Oxygen is liberated, D. Hydrogen is given off. Now, first things first, what is quicklime? Now, quicklime is the compound calcium oxide, and when calcium oxide or quicklime dissolves in water, when it reacts or is dissolved in water, the product given off is calcium hydroxide. And calcium hydroxide is also known as slaked lime. Slaked lime. Now this reaction between calcium oxide and water, or quicklime and water, is exothermic. is an exothermic reaction. And an exothermic reaction is a reaction, simply put, where heat is evolved. Heat is evolved or given off in an exothermic reaction. Another way to put it, the enthalpy which is a unit used to measure the quantity which represents the equivalent of total heat in the system being this reaction. Now, the enthalpy in an exothermic reaction is negative, and negativity shows that heat is lost. So from this reaction, or from this analysis, when quicklime dissolves in water, it gives slaked lime, and we have established that the reaction is exothermic. Hence, the answer is B, which is heat is evolved. So please subscribe to this YouTube channel for more videos and for more past questions and answers. I'm going to be answering WAEC 2019 Chemistry Objective Past Question 25. If the value of change in heat, that is delta H, is positive for a reaction, it means that the reaction is A, exothermic, B, endothermic, C, spontaneous, D, slow. Now, delta H, or change in H, represents enthalpy, the enthalpy in a reaction, or the enthalpy in a given system. And this enthalpy is a thermodynamic quantity which is equal to, or which can be referred to as, the total heat or the total heat content of or in a system. So that is what delta H stands for. Now, an exothermic reaction is a reaction where heat is evolved, and if heat is lost, that means delta H since heat is lost, delta H is negative. For an endothermic reaction, heat is gained or heat is absorbed. Therefore, delta H is positive for an endothermic reaction. Now, a spontaneous reaction is basically a reaction that takes place on its own without intervention, and you cannot specifically say if a spontaneous reaction loses heat or gains heat. So the enthalpy of a spontaneous reaction is dependent on other factors, such as it being endothermic or exothermic. Now, a slow reaction is one in which the rate of the reaction is low, or the time taken for the reaction to be completed is low, it's very slow. So by these definitions, an exothermic reaction is negative enthalpy, an endothermic reaction is positive enthalpy. So from the question, it asks for positive enthalpy, and we have established that it is an endothermic reaction. So our answer will be B, which is endothermic reaction, where delta H or enthalpy is positive. So please subscribe to this YouTube channel for more videos and more past questions and answers. So I'm going to be answering WAEC 2019 Chemistry Objective Past Question 26. Which of the following compounds is formed by the oxidation of ethanol? A. C2H4CO2H, B. C2H5CO2H, C. CH3OH, D. CH3CO2H. Now, first things first, ethanol belongs to the family of organic compounds known as alkanols. And alkanols are known for their functional group, which is OH. So they are known for having an OH functional group attached to them. And the chemical formula of ethanol is C2H5 OH. So you can see that ethanol has the functional group OH attached to it. Now, in the oxidation of ethanol reacts with a compound known as sodium dichromate. Sodium dichromate. It is the first stage in the oxidation of ethanol. So sodium dichromate reacting with ethanol to produce ethanol represents the first stage in the oxidation of ethanol. And ethanol undergoes further oxidation to give the product of the reaction, which is acetic acid. Now, acetic acid is also known as ethanoic acid, and is represented by the formula CH3 CO OH. And CH3COOH can also be written as CH3 CO2H. The reason is because here you have two oxygen atoms, so represented by CO2H. So that is the process of the oxidation of ethanol. You have ethanol first being oxidized by sodium dichromate, which has a formula of Na2 Cr H2O7. So sodium dichromate oxidizes ethanol to give you ethanol, which is then further oxidized to acetic acid. And acetic acid is also known as ethanoic acid and represented by this formula CH3COOH, which can also be represented as CH2CO2H. So by going by that explanation, the answer is D, which is acetic acid or ethanoic acid. So please subscribe to this YouTube channel for more videos and also for more past questions and answers.
That's the new thing. It's how that we make that. That's go campus. It's not easy to be like it before. Campus was public of intellectual property of people browsing, going up and down. They kill education, they kill everything, kill economy. It's bad.
Chika, how are you?
Hello.
Yeah, Chika, how are you?
Hi, sir. Good evening.
Yeah. Please let me know if you can see my screen for what is it called? Question.
Yes, it is.
We are starting from the chemistry. Where did we stop the last time? Okay.
Hello.
Yes, I can hear you. Can you see my screen now?